In this lesson, we work on applications of derivative in mechanics. Our goal is finding a relationship between the instantaneous velocity and the instantaneous acceleration of an object and the position of the object that is moving on a straight line. We know average velocity is the ratio of change in displacement over change in time. In other words, average velocity is average rate of change of position of the object with respect to time. And average acceleration is rate of change of velocity with respect to time. When delta t approaches 0, delta s over delta t would be the derivative of the position function. And average velocity would be the instantaneous velocity. Similarly, when delta t approaches 0, average velocity becomes instantaneous velocity and delta v over delta t becomes dv dt. In other words, if an object is moving on a straight line and position of the object is given by a function s at t, velocity of the object is the derivative of the position function and acceleration is derivative of velocity. Since velocity is derivative of the position, acceleration is derivative of the position, which is shown by s double prime of t, and it is called the second derivative of the position function. Generally speaking, derivative of a function is called second derivative, and similarly we can define the higher orders derivative. Let's have a couple of examples. Let's assume an object is moving in a straight line and its velocity is given by vt equals 92 minus t when t is in seconds and v is in meters per second. Find the acceleration of the object at t equals 2. We know acceleration is derivative of velocity. Derivative of 92 minus t is 18t minus 1. Therefore, acceleration at time t is 18t minus 1. This means acceleration after 2 seconds is 18 times 2 minus 1, which is 35 meters per second squared. Example 2. S at t, the position of an object that is moving on a straight line, is t3 minus 3t2 plus 3t plus 5. Find velocity and acceleration of the object at t equals 2. We take the derivative of the position of the function. We find velocity at time t. Derivative of velocity, which is 6t minus 6, gives us the acceleration at time t. Velocity after 2 seconds is 12 minus 12 plus 3. It is 3 meters per second. And acceleration at t equals 2 is 12 minus 6, which is 6 meters per second squared. Since both acceleration and velocity are positive, the object is speeding up. And since velocity is positive, object is moving in the positive direction. Example 3, s at t equals negative 4.92 plus t plus 1. For the object is moving on straight line. T is in second and s is in meters as usual. Find the initial velocity of the object. We are looking for velocity of the object. We take the derivative of s at t. Initial velocity means velocity when time is 0. Initial velocity of the object is 1 meters per second. Thanks for watching.